Hi, welcome to this course. This is Muhammad Yaqub. I am the founder of. In this project, we are going to learn about AI-based facial emotion recognition. So, facial emotion is the main requirement for many different kind of application. For example, when it comes to women's safety, if woman walking around some street and then is opposite gender who is talking to the woman, if they are like speaking like with lot of anger, then that's a kind of a bad situation. In some scenario, we have to capture that situation and then inform it to the nearby or else a relative of that woman, so that if there is any like kind of critical accident or situation going to happen for woman, no, we can able to prevent it, we can able to identify and can take the action necessarily. In same like, for example, if we can take any kind of retail store, for example jewelry shops, if we have any kind of display system of jewelries, so when some customers coming into store, when they are seeing different kind of jewelry, what reaction they are seeing towards that jewelry, what kind of emotion towards that product, so that and all we can able to capture. Like that, there are a lot of application for facial emotion recognition. We can use it for like a good thing, and we can able to use for security kind of purpose also. So in this project, we are using YOLOv9 architecture to identify the face, and then we are going to identify the different kind of facial emotion. And also we have developed a mobile app. Whenever some kind of abnormal emotion activity, we will trigger the notification to the mobile app, so that this kind of concept can be used for final year project, and then like this kind of project can be used for women safety kind of thing, like a jewelry kind of thing. If there is any kind of like negative kind of incidents happening, the notification will help police department or else their relative to rescue the person or some kind of similar things. So in this project, we are using YOLOv9 architecture. Using YOLOv9, we can able to detect the faces, and also we can able to detect different kind of emotion activity. Whenever there is abnormal activity, we also developed a small mobile app. In that mobile app, we can able to get the notification whenever the abnormal emotion is triggered.
We are going to use the Python programming language to implement our entire project. For that, we need to install a Python IDE. We are going to use only a specific version of Python for implementing our entire project. For that, we need to install Python 3.12. And if you have already installed any other version of Python on your machine, then it must be uninstalled from your machine. So let's see how to install Python on your machine. First, you need to go to Google and type in Python 3.12 py release. Then scroll down. Select the Windows installer 64-bit. Then simply click to run it. Then select Add Python to Path. Then click Install. Now Python is successfully set up on my machine. Then close it. Now we can go and check the Python version using CMD. py-hyphen version. On my system, the Python version is 3.120. Now we can go ahead and implement our project. Before implementing and executing any part of our project, first we need to install VS Code on your machine. And if you already installed VS Code on your machine, then that's perfectly fine. This guide is for those who have not yet installed VS Code on their machine. Let's go through it step by step. VS Code is a platform that makes it easy to build applications. To install VS Code on your machine, first you need to go to Google and type VS Code. Then press enter. Select Visual Studio Code from the results. Then click on download for Windows 10 and 11. Now the download has started. We need to wait a few seconds for the download to complete. Now VS Code has been successfully installed on my machine. Then I go to the folder. Then right click on the file to install. Next, accept the agreement and click next. Next. Yes. Next. Next one. Install. We need to wait a few seconds for the installer. Now VS Code has been successfully installed on my machine. Then click finish. Now we can go and check the version of VS Code using CMD. Then type CMD here. Type code version. The VS Code version is 1.953, and now we can implement the project step by step. I'm going to give a brief overview of the project. The project is called Face Emotion Reduction. In this project, we look at some key aspects of reducing and recognizing facial expressions. The classes are sad, happy, angry, and surprised. These are the classes we will detect and recognize using the advanced YOLOv9 algorithm, and we will use a custom dataset from the RoboFlow website. Then comes the training. Once the model training is finished, we will perform inference using VS Code, then stream the live video to a mobile application and send a notification to the mobile app whenever an expression is detected. This is a brief overview of the project. Next, we will see how to train facial emotion recognition on the Google Colab platform using a custom dataset. First, you need to open Google, then type Google Colab here. Then, welcome to Google Colab. You simply need to upload the required facial emotion recognition IPYNB file here. Please drag and drop it. Once it is successfully uploaded, you need to connect to a T4 GPU. Once the notebook is successfully connected on the Colab platform, which means your environment is ready for use, you need to obtain this file by following the instructions provided in the notebook interface. Colab, which is provided by Google, is an open source platform, and the GPU is free to use for up to 6 hours. After that, the connection will be disconnected and you can only get a new allocation the next day. Before that happens, we can train our model within that time period. This is an overview of Google Colab. Next, we need to mount Google Drive to access or store files in Google Drive. To do that, we need to connect to Google Drive. Then select your account. Then click continue and continue again. Now, Google Drive has been successfully mounted on Google Colab. Next, you need to download the dataset from the RoboFlow website. First, you need to install RoboFlow. We are going to download the dataset using an API key. The name of the dataset is Facial Emotion Recognition. This is the name of the dataset being downloaded from the RoboFlow website. The dataset version is 5 and the dataset download format is YOLOv9 format. The dataset has been successfully downloaded, and this is the name of the dataset folder which contains the test set, training set and validation set, and this is the data OML file. Here we need to change both the image folder path and the label path. We don't need the test folder, so I remove it. These are the class names: angry, happy, sad, surprised. Number of classes 4. Then I am going to copy. Next, I'm going to copy the validation folder path. After that, you need to save it. And this is the dataset visualization. We are going to display up to 25 images from the images folder. This is the function to display images. We need to call this function with the image paths, a title, and the number of images to display. And then shuffle the data set. Then set the minimum number to 25. Then get the minimum number of images. Next, this is the x-axis, which is used to plot the images here. Then set the figure size to 12 by 12. Subtitle. I take the images one by one using a for loop and enumerate. Then PLT subplot. Then open the image and then convert it to grayscale. Then set the title axis off. Then as you can clearly see, these are the images. Next, download the official YOLOv9 from the official GitHub repository. Then change the current working directory to YOLOv9. Then install the required packages using the requirements txt file. Then I'm going to install the packages have been successfully installed on Google Colab without any issues. After that, you need to replace this code in the plots of file. The line number is 86. You need to open YOLOv9. Go to utils, then plots, and then go to line number 86. Just comment this out using control/, then press enter, control/ again, and then copy and paste it into this file. The line number is 87. You need to add a tab space. If there are no errors in this file, then save it. After that, you simply need to restart the section. Now we can go ahead and run this cell to execute the code. After that, you will need to change the working directory to the folder named YOLOv9 by using the appropriate command. Once you have switched directories, you should check and confirm your current location by running the pwd command to make sure you are in the correct place. Now the working directory is content. So move into YOLOv9. Then download the pre-trained YOLOv9 EPT for your project by visiting the official GitHub repository page and locating the download link provided there. You can check the YOLOv9 folder to see that the YOLOv9 EPT file has been successfully downloaded and stored in the YOLOv9 folder. Next, we are going to look at model training. YOLOv9, which stands for You Only Look Once, is now in its 9th version. This algorithm is used for object detection and object segmentation tasks in images or videos, and it is an advanced version of the previous YOLOv7. The model parameter size has been reduced by 42% compared to the existing YOLOv7 and weight algorithms, and the model's accuracy also surpasses that of the existing YOLOv7 version. Additionally, the map is also better than the previous YOLOv7 version. ArgParse is a library used to create or build your arguments one by one. especially for YOLOv9 parameters such as the model file, configuration file, hyperparameter file, and batch size settings. Then there's the math module, which is used to perform mathematical operations. OS is a basic Python library that is used to perform basic Python operations. Random, which is used to select random data. Then sys, which is a basic Python module that can perform some basic operations. And time, which is used to get the total inference time or the current time. Then deep copy, which is used to copy data. Then import date and time from date and time, which is to get current date and time. Path, which is used to access a folder path. NumPy, which is used to handle RF data. Torch is a deep learning framework used to implement deep learning algorithms. And then distributed as dist, which is used for multiprocessing tasks. Then import neural network using torch.nn. This is the OML file, and then the learning rate scheduler, optimization, and TQDM, which is used for the progress bar. This is for validation, which is used to check whether the model is loaded. Then models, input model, then auto anchor, auto batch, check train batch size, then callbacks, which are used to store the best model weights, then load dataset, and then create dataset, attempt download, and then is URL. This is used for checking image size, checking files, checking the dataset, and then logger info, then checking commit resume, and some plotting libraries, early stopping, and deparallel, which is for setting CUDA, smart optimizer, smart resume, and finally pandas, which is used here to construct arguments using pandas series. The program execution begins with this function, which is called the main function, and it contains a single Python function. The function is named parse out, and within this function, it takes arguments related to the YOLOv9 model. The arguments include weights, which are used to load the pre-trained model weights. The model is named YLAN-CP, which refers to the YOLOv9 folder. And there is also a configuration file that specifies the number of layers in the model, along with other important model configurations. Next, the dataset is loaded. The dataset YML file is located in the facial emotion recognition folder, and hyper refers to the hyperparameter file, which is used to improve the model's performance. And then the number of epochs is set to 50. If you read the book once, that's called 1 epoch. If you read the book 100 times, that's called 100 epochs. So when we set it to 50 epochs, it means the model will learn from the dataset for up to 50 epochs. The batch size we set is 16. This means that for each learning step, the model processes 16 images as a batch. The image size is set to 640. This is the standard size for the YOLOv9 model. Next, the resume option is set to false for everything. Then evolve is set to 300. Next is cache memory. This folder is used to store the outputs of the YOLOv9 model, such as confusion matrices, graphs, and other important graphs, model weights, and batch outputs. Next, there is an express folder specifically. Then patience is set to 100, opt freeze is 0, which determines whether to use all parameters or not, followed by logger arguments, and then comes the main function. At first the model hasn't been trained yet, and we also don't have the model file, so we can't use the resume option. But if the model has already been trained for say 20 epochs, then we can continue training from that point by setting resume to true. Check if there is any model file in the folder, then look for the opt YML file, opt data, and then this part which is for loading dataset, YML. Next, there's a step to load the pre-trained model. Check if there is any space present in the arguments. Then comes the configuration, followed by waits and resume. Then verify that the files are correct and record the time when the program execution stops. Initially, this condition will not be met. Then the else condition is satisfied and opt data, opt config, opt hyperparameter, opt weights and opt project are set. The model weights must be present in the YOLOv9 folder. Otherwise, an error is raised using the assert keyword. Next, this is just to store the model training results. Then opt resume is initially set to false. Then opt name is set equal to the configuration. Then access that configuration file path. Distributed data parallel mode is used to allocate a training process across multiple GPUs. We set opti device to 0 because a T4 GPU is available on Google Colab. If local rank is not equal to 1, then compatibility with multi-GPU DDP training is not possible. Then an error is displayed. Then this condition is satisfied because opt-val, which we have set, is 300. Then directly call this function by providing it with the hyperparameter file, which contains all the necessary configuration settings as well as the opti device parameter to specify the computing device and the callbacks that will be used during the process. This is the train function. It receives arguments such as the save directory, batch size, weights, single class evolve, and the remaining parameters which are then used to store the model weights in the specified folder. Weights, and then this refers to the last weight and the best weight. The best weight is saved whenever the map increases. Then this is the function used to load the hyperparameter file. Actually we set evolve to 3, but under this condition it is not satisfied. Then the dataset is loaded and plots are configured, which includes plotting graphs such as the loss graph and the confusion matrix. Next, we actually set the device to CUDA, which means using the GPU. For each seed, it selects a random dataset every time. Torch distributor sets the local rank to 0, loads the dataset and trains on the validation path with 4 classes in the class names. Then it checks if there are any PT files present in the YOLOv9 folder. Actually, there is no custom trainer model PT file present. A pre-trained model is only available if pre-trainer is set to true. In that case, the pre-trained model weights are loaded. If it is not available, then the model is created from scratch. Then freezing is applied. Do you want to use all the parameters or just half of the model parameters? Next is the image check, specifically the image size. In fact, we set the image size to 640. Then verify the image size for images available in multiple image paths. Whenever you are going to train a deep learning model, the model's input size must match the image size, and this must be consistent for all images as well. Next, check the batch size. Normally the batch size is 64, but in our case we set the batch size to 16. Next is accumulation, which is used to enhance the loss. Learning rate decay is used to control the processes we reach the target or find the optimal loss or approach a local minimum. We need to stop adjusting the learning rate, and this is managed using weight decay. Then comes the learning rate scheduler, which determines how well and how quickly or slowly the model learns as controlled by the learning rate. Then after the learning rate scheduler, there's EMA, best fitness, and the starting approaches. Initially, these are set to 0 if using a pre-trained model and if using ResNet. Next is DP mode, where it checks if CUDA is available and if the rank is available. Then it gets the count of CUDA devices. If this condition is met, then distributed data parallel is applied. This is for synchronization, which is used to run multiple batches at the same time. Then load the training dataset with some parameters, training path, image size, batch size, world size, and then concatenate the labels, set the maximum number of label classes, and finally just load the validation dataset. After that, first apply small DTP, next use deparallel mode, and then carefully set the following hyperparameters. label smoothing, number of classes as a hyperparameter, and finally assign labels to classes with a set. Then initially set the time to 0, get the length of the training loader, set up warm-up approaches, and map. The map value ranges from 0 to 1. If it is close to 1, the model's performance is good. If the value is below 0.3, the model has not performed well. Then the results are initially set to 0, precision, recall, map at 0.5, and from 0.5 to 0.95. And then validation. This is the box loss, this is the object loss, and this is the classification loss. Then start the approach at -1. This is the scheduler, then the scaler, early stopping. If the model's map does not improve after certain attempts, then stop the execution using early stopping. The model can only learn exactly the same thing in repeated attempts. After that, you then compute the loss, run the necessary callbacks, display the current image size, use the login result, and start the training process. Then the model execution begins from this for loop, and then finally outputs the results. Image weights are not obtained. These are the class weights, image weights, and the round weight. And then this is for the main loss, which is used for detection loss. And then it enumerates the objects. This is logger info, epoch, GPU memory, bounding box loss, classification loss, DF loss, and instance. Then apply CUDA to the image, followed by warm-up, which is used to display the running results. Next, accumulate, then apply the learning rate and momentum. Momentum is also a parameter used to sufficiently stabilize gradient descent. And then comes multi-scale. Multi-scale is enabled, which is used to make some adjustments to the detection bounding box, and then forward, which is the prediction step. So once the model predicts the image, it is then compared with the actual values in the predictor, and the loss is computed. Then compute the loss using the compute loss function. They needed to provide the model output here, and then the devices could process it, followed by updating through backpropagation, and finally the result is fed into the loss function, after which the model is retrained based on this latest value. Optimization is a technique used to update the model's weights during the training process, such as weights and biases, which determine the model's performance based on the latest value of the model. And this involves the loss optimizer step, then accumulation, then scaling, handling unskipped gradients, and normal unscaled gradients, which are used to update the gradient values. A gradient refers to a small change in the slope. Then in optimization, you zero out the gradients and then display logger information such as the mean loss, targets, and then the scheduler, which is the learning rate scheduler. As you already know, the learning rate scheduler is used to the model may want to reach a decision quickly or arrive at a destination more slowly. Next, we specify the number of classes, hyperparameters, their names and states. And then this part is for the validation data. Once the model is finished, first we perform inference, then run the validation function to evaluate the model's performance on the validation data. For the validation data, the model doesn't learn from the entire data set. So we need to provide data that the model has not seen before. Then update the best mean average precision map based on the validation results. Save the best model weights. Then delete the previous model weights. Next, apply early stopping. At the end of training, display the logging information. This marks the end of the training. Finally, return your results. Then clear the CUDA cache with torch, CUDA empty cache. and this is the hyperparameter file. It includes the learning rate momentum, weight decay, warm-up steps, warm-up momentum, and then the bounding box value classification loss. This is for deferring the classification loss. This is used to load the hyperparameter file. Then the anchor is for making small adjustments to the bounding box. This helps to improve detection accuracy. This is for storing the loss value and accuracy in evolve. CSP, this is the output parameter which is used to store data in the CSP file, evolve, CSP. Then mutate, retrieve the hyperparameter files, keys and values, then callbacks, keys for precision, recall and map metrics, and finally plot your results. Next, we'll see how to train the YOLOv9 model using a custom dataset. First, we need to check whether the file paths are correctly specified or not. We need to open the facial emotion recognition 5 folder. It's opening now. It has been successfully opened in the folder. Next, I'm going to open data OML, which contains the class names angry, happy, sad, and surprised. Number of classes 4. And then this is actually the training path. This one is the validation path. Now close this data OML file. Then you need to open the YOLOv9 folder. Then you need to go to data, then pipes, open this hyperparameter, scratch I OML file. Then you need to comment using the hash symbol. Then finally we need to save it. Then close this file. Then you simply need to open plots. Utils. Then scroll down and open plots. Make sure that it must be replaced with line 86. It absolutely must be replaced with these 2 lines right here. Then you need to save it and check the current working directory using pwd content YOLOv9. Then now execute this cell, then execute. And I'm going to execute this cell. Now the training has started successfully, which is validating the dataset. So the first step has started successfully. It starts at 0. The total process, we are going to train up to 10 new epochs. This is actually an image taken at night. This one is the last data. So we have to wait until the training process is complete. Let's wait. Now the model training has successfully completed up to 10 new epochs. These are the actual metric values: precision, recall, and map at dot 5, map at dot 5 to dot 95. This is the outclass accuracy score, which is based on the total number of images, which is 892. And then the number of instances is 948. This is the precision and recall score, which are 0.9 and 0.88 respectively. This is the MAP, which is used for evaluating detection and classification metrics. Then there's MAP, which is also in the range of dot 5 to dot 85. This is the overall accuracy of the model, and this is the individual accuracy of the model. Then 94 is the precision and recall, and then this is the map from dot 5 to dot 85, and the model results will be stored in the face emotion recognition weight 5 folder. You need to open Google Drive, then go to My Drive. In the face emotion recognition folder under weight 5, you'll find the weights, which include phone, score, precision, recall curve, PNG, precision curve, and recall curve. And then there are results, CSV and results, PNG. In this weights folder, you will find best, PT and last PT. Finally, we'll see how to perform inference using this trained model. Finally, we are going to perform inference using the trained YOLOv9 model. The model file best PT must be located in the face emotion reduction project folder. Next, you need to enter the following command here in the command prompt. Then type code. This will open the project in VS Code. Now VS Code has opened successfully and the project folder is named Face Emotion Reduction. Here is the YOLOv9 library with folders named models, panoptic, runs, segment, templates and tools. This is the pre-trained YOLOv9 model best PT along with config.json. The file direct py is used for the final inference. Next there is export py and this is the requirements txt file which is used to install the necessary libraries for inference. First we need to import the necessary libraries to perform inference using the trained YOLOv9 model. The first library is torch, which is used to load a pre-trained YOLOv9 PT model file. Next is threading, which is used for multiprocessing tasks. The OS library is a basic Python library used to handle some fundamental Python operations. The platform module is used to access system platforms such as Windows, Linux or Mac. Then TS is a basic Python library that is used for some basic Python operations. Socket is used to send data, but here we are going to use it to access the machine's IP address. Next is MQTT, which is a protocol used to send and receive data over the internet. Then there's requests, which is a method used to send data. Next is JSON, which is used to load files in JSON format. Then NumPy, which is used to handle arrays of data. And finally, a module used to load the renderer template HTML file. Then there's Flask, which is an API used to send and receive data via API. Next is Flask course, which is simply used to prevent course policy errors. Then renderer temp by response, JSON, which is just to return a response in JSON format if we format it that way. Then we import time, random, CV2 and path. This is YOLOv9 along with some imported libraries. Next is the initialization of the socket using socket, and these are the parameters for the socket. Then S connect with this specifies the port and then retrieves the IP address of the machine. After that we define our Flask app. Flask itself is a class. Then we create an object for that app. This is the function name. Next we apply the course policy, and then the output frame, which is initially set when the program starts running, will be stored in the output frame variable. A lock is used here for multiprocessing tasks. Next, we define the MQTT server address, which is broker IOMQ.com. This is the client name, which is project. Then we connect to the MQTT server. Next, client message is a function used to receive data, and then we define a server token as well as an emotion reduction flag, which is initially set to false. So once an emotion is detected, this flag will be set to true. On message is a function used to receive data published via MQTT. This is the payload message, payload decoded in UTF-8. Then the received string is split and the data will be stored in config.json. This is the start execution function. An API used to get emotion detection updates, and then the program execution begins from this function using threading. Model inference is a function that is defined further down in this code. Then it runs with a daemon thread. Next, tstart is called. Once the program execution has started successfully, it returns success. Then update status, emotion is detected, and this is the index HTML API which is used to load index HTML. Then initially CocoYML is set. This is the name of the dataset. Then delurally detag, which is initially set to false. Then device, which runs on the CPU. Once the model is trained with the GPU, after that inference will be performed without using the CPU. Then access the device information, which is the CPU. Next, ARF denotes FP16, and then detect multi-backend, best, PT, Then device this is a model configuration used to load the pre-trained YOLOv9 model. Then FP16, which is ALF model infer, is a function used to make inferences with the trained YOLOv9 best PT model. Now we need to provide some important arguments to this function. The weights variable is used to store the best PT file. Then source, where we have three types of input videos. The input videos are input on MP4, input 2 MP4 and input 3 MP4. This is the COCO dataset path, COCO YML. The model is trained with an image width and height of 640 by 640. Then the confidence score, which is initially set to 0.2. Next is the IOU threshold, which is used to filter out redundant bounding boxes for the same image. Then the maximum detections per image. Then the device, which is set to CPU. Next, view image, which is just to display the results. Then save tags is false, save confidence score is false, save crop is false, and not save is also false. Then project is run detect, then experiment name, then exist, okay, and then access the output frame, lock, and the emotion detector and the model are accessed using a global variable, which is just to access variables from outside the function. The initial notification flag is set to 0 and the normal flag is also 0. Then the source is converted into string format. They do not save and do not include the source inside the txt. Actually, this is a file, but this is actually not a file. This is also not a URL. And then the webcam is also not going to be used. We are only going to use the three types of input video. Then screenshot is converted to lowercase, then starts with screen is, URL is, file are actually false. This is a directory that is just used for incrementing and for storing results. And then the device is selected, which is actually the CPU. Then access the style names and the PT from model styles as well as the number of styles. And then from model names and model PT, check the image size, which we initially set to 640 by 640. Then the batch size, which is 1. So actually we tried using up to 16 as the batch size during the training process. But when we provide a single input video and process each frame individually, we need to set the batch size to 1. Check if it's a webcam, then check if it's a screenshot, then load the image, and then this is the model warm-up, which is meant to perform inference using this PT model. After that, observe in Windows DT, then the dataset processes each frame one by one, which is accessed using the video capture function. This is the M0 IMTH, this is a video cam. Then next it starts with MQTT, which keeps running continuously. Client, load stop, which keeps running indefinitely until we stop the execution of the program. Then with DT0, we convert it into a torch tensor from a NumPy array on the model device. Then apply all, which runs FP16, and then normalize the values between 0 and 1. Next, we check whether the length of the shape is 3, and then the inference results will be stored in the same directory folder. These are the prediction results. Then we apply non-maximum suppression, which is used to prevent redundant bounding boxes for the same image. Then process the predictions one by one using a for loop or an enumerate object. And this contains the detection information such as the confidence score and class name, as well as the bounding box information like zone, yone, x2 and y2. Increase the value of the variable c by 1 using c plus equals 1. This is actually not a webcam input feed. In fact, the input video is fed to the model for inference. Then the else condition will be met. Next, access the frame im0 and the prediction results. Then access the path, followed by save, path, and then the txt path information. This is actually s plus the print string, then torch. Tensor normalizes the gain with the node. This is the copy information. This is the annotation result, which is simply drawing a rectangle box on the output video frame. Then check the length of data. This contains the detection information such as the bounding box, confidence score, and class name. Then print the results here. It returns the results one by one using a for loop and then obtains the unique data. This is the number of detected classes. This is the class name and this is the class confidence score. S is a class name, and if the confidence score is greater than 0.2, then we will process that data. Otherwise, we will not process it. If the notification flag is 0, then publish the data to the mobile app using the OpenConfig JSON, which is used to load and store the config JSON. Then the device token followed by the headers and body. Then increment the notification flag to 1. Then if an emotion is detected, this is set to true. If the emotion is not detected, then the normal flag is set to 0. Then client publish emotion 80, the notification flag is 0 and the normal flag is 1. This block of code is simply for writing the information to a txt file, and then it streams the annotated results from im0. If view image is actually set to true, then this condition will be met. Then the image is resized to 640 by 480 and the output frame image is raised without copying. The generated function is used to convert binary data. Then it accesses the global output frame and log variables and keeps running as long as the log condition is satisfied. If the output frame is none, then it continues. If the output frame is not none, then it saves it to an encoded format. This is the encoded format data. The flag is either true or false. The encoded image will be stored in the encoded image variable. If the flag is not set, then continue. This is in byte array format. This is the video feed API which is used to stream live video here on the web browser, and then generated is a function, and the media type is multipart. Xmix replace with a boundary frame, and then the program execution starts from this main function. Start confirmation. Do you want to start the execution? Yes. If the answer is not yes, then the execution does not start. And then once the Flask application has started, it will display the IP address of the machine. The host is set to 0, 0. The port is 8000, threading is set to 2, and use preloader is set to false. Finally, we are going to execute a delete py. First, I need to install the requirements, txt libraries, torch, vision, ipython, flask. So first I'm going to open our terminal, open a new terminal, and then I'm going to type here pip install hyphen or requirements txt, then give him. Now the packages are installing and they have been installed successfully. Then I'm going to get the redacted py file, copy its relative path, and then clear the terminal. Then type python, paste the redacted py file path and press enter. Now the program execution has started successfully. So next I'm going to do this. Yes, this is the IP address of the machine. My IP address is 10.147.23.139 and the port is 8000. Then I'm going to copy this URL. Copy it. Then you need to go to Google and paste it here. Then you need to type here. The username is 1. Then the password is 1. And you need to paste the IP address of the machine 10.147.23.139. Then the notification topic, which is the emotion entity, then the emotion reduction topic, which is emotion UT, then click login. Now the model inference has started successfully and it is processing the frames one by one. I have provided the input 3M4, which is being processed frame by frame. This is the output given by the model, which is sad with a confidence score of 0.71%. The person is indeed showing a sad emotion. Next, I'm going to provide another input video, which is input video 1, MP4. First, I'm going to stop the execution of the current program with Control C, then clear it, and then you need to refresh it. Next, I'm going to change here input 1, MP4, then save it, and then I'm going to run it again. Now the program execution has started successfully. Then I'm going to enter yes, then go to Google and refresh the page again. Then I'm going to enter 1. The password is 1. Then the IP address. Then the notification topic, emotion reduction topic, emotion 80, then login. Still no immersion has been detected. And then model inference, which is happening now, is processing each frame one by one. And still no emotion has been detected. Now the emotion that is detected is predicting angry for the man, which is a truly angry emotion. With a confidence score of 0.4%, it is processing each frame one by one. Angry 0.42%, and I'm going to stop the execution of the program. I hope you were able to understand everything the way I explained it. This includes the explanation of the project and how to execute the code. Suppose if you have any doubts regarding the project or how to execute the code, please share your thoughts in the comment section. I'm ready to help you. Thank you.
Hope you enjoyed the course. Course will surely give you solid foundation in computer vision, and then it will help you on your final year projects also, and then surely it will help on your cracking your job interviews. While implementing this project, if you face any kind of difficulty while implementing the project or while setting up an environment, or if you get any kind of doubt, you can feel free to put in the comment section. We will surely help you in as soon as possible in a better way. Thank you.